I'm really excited to be here. This is my first time in Poland, so all of the food's been amazing so far, and I'm really excited to just kind of tell you a little bit more about functional magic in Swift. So I'll just start by telling you a little bit about myself. I'm a software developer at a company called Slalom. They're around the world. They're not in Poland yet. I think the closest office is in London. I live in St. Louis, Missouri in the United States. And if you want to ask me any questions or really just talk to me in any way, you could tweet at me, look at any of my repos on GitHub, or you could send me an email. So when Swift first came out, everyone was really excited because they took a lot of different things from a lot of different functional programming languages and put it in Swift. And so over the course of Swift, we're at Swift 5 right now, but they've been adding more and more functional components to it. And a lot of you have probably wanted to learn more about reactive Swift, kind of like me. So the first thing that you probably saw were that there are a lot of these new functions in Swift: map, flatMap, compact map, filter and reduce. Like I was saying, there's all of these functions that you've probably seen, and we're going to actually go into these in more detail. But the first time you look all of these functions up, you end up seeing something where they start talking about functors and monads. And if you're like me, you're like, I have no idea what a monad is. So you probably went and Wikipedia'd it. And the first time I went and Wikipedia'd it, it basically said this. It said, this article needs some attention from an expert in functional programming. It doesn't succinctly explain it, blah, 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 blah. I just Wikipedia'd it again yesterday, and it says this article is still too technical for most readers to understand. So, I mean, that kind of sucks, right? If you're like me and you're like, well, hey, I want to learn functional programming. They're telling me I need to learn about monads, and I look up monads, and it gives me this kind of, you know, this thing that says, hey, you know, this is what functional programming is. Here's a monad. And it kind of tells you a monad's a design pattern that defines how functions, actions, inputs, and outputs can be used together to build generic types. Step 1, you define a data type and how values of that data type are combined. 2, you create functions that use that data type and compose them together into actions, following the rules defined in the first step. I could read that over and over for days, but honestly, this is how I feel about it, right? Like the first time you read this, you're like, I have no idea what this means. So hopefully we won't be as overwhelmed as I was the first time that I read it, and we'll kind of go through it in steps with examples so you could actually hopefully understand what that definition means now. So luckily for you, maybe unluckily for you, especially if you can't read my handwriting, I apologize, but I drew all of this out with cupcakes. If you know anything about me, I love cupcakes, really excited about it. I also love Swift, as you can see with the Swift-themed necklace and skirt. And so I really wanted to bring these two loves together. I also love Taylor Swift, so you'll also see a lot of Taylor Swift references too. But this is just like my happy place. So first things first, I'm not force unwrapping cupcakes, I'm just really excited about them. But a box of cupcakes will be represented by an array of cupcakes, as you can see here. The cupcake class has 2 attributes, frosting and cake. Frosting is optional, obviously, because you don't need all cupcakes don't need frosting. And then there are 2 functions on a cupcake. You could frost a cupcake, and that just takes your cupcake that's unfrosted and returns a frosted cupcake, and then you could get the flavor of a cupcake, which will return a string. Okay, so let's talk about map first. Map is just looping over a collection, which could be something like an array or a dictionary or something like that, and then applying the same operation to each of the elements. So the old way we would do this, if I wanted to frost my entire box of cupcakes, I would say for cupcake and cupcakes, in my array of cupcakes, let a frosted cupcake equal cupcake.frosted, and I would frost each cupcake. And so we would go through and we would frost every single one of these cupcakes. Cool. Now the new way is actually pretty easy. We would say let frosted cupcakes equals cupcake.map $0.frosted. Now I'll actually go over the syntax a little bit more, but I wanted to show you first off that it's actually really simple and a one-liner to be able to go over an entire collection and do the same thing to it. So similarly, if we wanted to get every single cupcake flavor, the old way would be we would make a new empty array of type string as the first thing, and then we would go through and we'd say, okay, get the cupcake flavor, then get the flavor and append it to the cupcake flavors array, and you would have, what, 4 lines of code basically. The new way would just be initializing something called cupcake flavors and saying, hey, map that and get the flavor of every single thing. And then you would have this array that has every single flavor of each of the cupcakes, which is pretty nice. It makes it very simple to read. And you go from 4 lines to 1 line. So similarly, you could kind of see the old way is those 4 lines, and then the new way is just that 1 line. The next thing we're going to do is actually going to go over the syntax of all of this. And so all of the kind of functional programming syntax is a little weird. If you remember block syntax in Objective-C and how you always had to look that up, or at least I always had to look that up, it doesn't always entirely make sense, but we'll go over this and kind of think about it in a little bit. So the first one is the most explicit way that you could do this. So basically a map function takes a function in it. So you could kind of see the input type is called cupcake, and it's of type cupcake, and it returns something that is of type cupcake. And then you have the keyword in, and then you have the actual part of the function that you want to do. So in this case, we're going to frost each of the cupcakes. Swift is like ridiculously smart, right? So it knows, it's like, hey, I know that when you frost a cupcake, you're returning something of type cupcake. So we don't have to have that arrow cupcake in there. So that's cool. Similarly, it knows when you're mapping things from the array of cupcakes, we know that it's all of each of these cupcakes are type cupcake. So drop that type there too. So then we get to this third one where we're just saying, hey, every single item in the cupcake array is called cupcake. We're gonna now go inside the function and then frost each of the cupcakes. And so again, Swift being really smart says, hey, you don't really need to name it. If it's just the first thing, we're gonna give you a shorthand syntax of $0. And so that's why you can see all this nicely done one-liners of just saying every single item in the array or the dictionary or whatever in the collection, that item can be denoted with $0, and then you could just put whatever you want to do in line in there. So that's pretty nice. All of these things are exactly the same. You can make it as long as you want or as short as you want. If you're working with people who are pretty new to this, make it longer, make it easy for everyone to understand. If you're doing the same thing a million times, do it as short as you want, whichever ones work. Okay, so let's just quickly go over map. Map takes a single argument of a closure. A closure is basically just a function. The closure takes each element from a collection, and then it returns a result. So it does something to it, and then it returns a result. And then the results are all kind of added together into an array that's returned. So that kind of went over arrays. If you want to do mapping on dictionaries, it does basically a similar thing. Each element is a key value pair, and the key is $0, the value is $1 in the shorthand syntax, but there's no sense of ordering like arrays, right? Because dictionaries aren't really ordered. So if we wanted to map with dictionaries, we would have a dictionary where the key would be our cupcake and the value would be the type of flavor of the cupcake. And so if I wanted to get all of the flavors from the dictionary, I could say, hey, cupcake dictionary, map $1, $1 being the value, and then you would get this nice array with all of the different flavors. Again, like I said before, they're not in the same order because it's a dictionary and dictionaries aren't ordered. You could also map with optionals, which is kind of interesting. So basically, if you want to map with optionals, so if I had a number of cupcakes and it was an optional integer, and I wanted to add 2 cupcakes to it, Swift would get really mad at you and say, hey, you can't add to an optional, right? You'd have to do something like if let number of cupcakes equals whatever, you know, and you'd have to unwrap it. Mapping actually will unwrap it for you. So what you can do is number of cupcakes.map, and you could add it inside of here, and it will return to you an optional 2. So basically, it unwraps something, it does whatever function, and then it rewraps it for you, which is pretty nice. You can use this in all sorts of places so that you don't have to keep doing if, let, whatever, whatever, and unwrapping things. It will just kind of automatically do it for you and then rewrap it. Okay, so let's talk about flatMap. So in Swift 3, there was a lot of different versions of flatMap, and then in Swift 4.1, they actually kind of broke out some of the versions and deprecated some of the things of flatMap. So, and now we're in Swift 5, and this still stays true. But flatMap's a little weird. It flattens a container, basically. And so I couldn't understand this until I saw a bunch of different examples of this. But again, people were describing it as it sees things in one less dimension, which again, like, what does that mean? I don't know. So say we had 2 cupcake boxes. So we have an array inside of an array, right? We have box 1 and box 2, and they're all in one big array. If I did a flat map on that, it would unbox it, and it would return only one array instead of an array of arrays. And so that's probably the most useful version of using flatMap that I've kind of really found. So if we were to do that the old way, where we'd want to kind of take out a dimension of arrays, we would have our 2 cupcake boxes, we'd make a new empty array, and then we would say, hey, go through every single cupcake in each of the boxes and add it to that new array, and then just have it like that. So it's kind of nice, and that'll give you a one-liner. So what is the first argument in a flat map, which is kind of weird. Some people will think it's just the number 3, but actually it's each of the arrays. So if you wanted to do something like, hey, double each of the numbers, you couldn't do this. This would actually fail, and Swift would say, hey, you can't double an array, what are you trying to do? So what you would end up doing is something like this, where you would do a flat map on, you would do this internal one where you mapped each of the numbers in the array and doubled each of the numbers, and then you would do a flat map. So the map would kind of double each of the numbers inside of the arrays, and then the flat map would kind of take that level of dimension out. So that's just one of the things that you'll probably trip up with flat maps. Okay, so flat maps take a single argument of a closure. The closure takes the element from the collection and then flattens the collection. So like you saw when there were nested arrays, it kind of took out one layer of arrays. And then you, similarly to map, you get the results as an array of the closure's return type. Compact map is actually the most useful version of old flat map. They renamed it to compact map because flat map was really confusing. Compact map kind of has a lot of roots in Ruby and other languages, so that's why they named it this. This came out in Swift 4.1, and this is a convenient way to remove optionals and remove nils from an array or a dictionary. Swift 5 actually came out with compact map values because you couldn't do compact map on dictionaries. Compact map values will just take out all of the nil values. But let's go over an example of this. So like I said, compact map deals with optionals and it removes nil values. So if I had an array of optional cupcakes, so you see a cupcake, a nil, a cupcake, and another nil, if I mapped over that, you would kind of see it would be, you know, an optional cupcake, a nil, an optional cupcake, a nil. But if I compact mapped over it, I would remove all of the optionals around the cupcakes. So I would be unwrapping the cupcakes, and I would be removing the nils. And this is really, really useful because we've all done stuff where server-side things give us a lot of nils, and we have a lot of optionals, and we have to go through, and we're like, hey, is it nil or an optional? If it's nil, get rid of it. If it's an optional, unwrap it. And there's just a lot of code around that. This makes it a nice one-liner. So, like I said, the old way is just kind of long, where you'd go, hey, for each of the cupcakes in the cupcake array, if the cupcake is actually a cupcake, append that cupcake, and then you would get these 2 cupcakes. I actually forgot in this example, these cupcakes are still optional cupcakes, right? I'm not really doing anything to, I guess I'm taking out the optional on the flat, but like, it's just a lot longer than the one-liner of, don't have a slide with the one-liner, but it's a lot longer than just saying compact map. So again, compact map, all of these kind of slides at the end of these are very similar to map. Compact map just also takes out nils and removes optionals. Okay, filter. Filter loops over a collection and returns an array that has elements that match an include component. So in this one, we would say that we only want cupcakes that aren't red for whatever reason. I love red, so I don't know why I made this the example. But basically, we'd have to make a new box of cupcakes. We would get the flavor of the cupcake. We'd try to see if it wasn't red, and then we would append it. In the new way, we would just say filter on if, so filter would take something like this, and this would be the include part of it. And if it doesn't match, get flavor. If the flavor is red, then keep it. If it's not red, then get rid of it. And you would just get back in a box of cupcakes with 3 cupcakes in it, which is pretty nice. So filter's different. It does take a single argument of a closure, but the closure takes elements from the collection and sees if they are included or not. So basically, if the include part returns true, it gets added back into the collection. If it returns false, it doesn't get added into the collection. And then lastly, we'll go over reduce. And reduce is probably the weirdest one, but basically it takes everything in a collection and then it returns one single value, which is pretty weird to see. So, like I said, reduce is really weird. Reduce takes in an initial value. So usually you'll probably start at like 0 or something. The next thing is you'll see that closure again. And the first thing in it is the results. The second thing would be the next item that you're trying to reduce, so the next item in the array. And then in this case, usually when you're reducing things, you probably just want to take an array of numbers and like make them into one number, maybe add them together, multiply or whatever. And because of that, Swift knows, hey, you probably want to just add all of your items together. So this is the shortest syntax. If you want to add every single item in an array together, you could either say add everything to the result or just add. I'm not really sure why they did this. I actually find it more confusing when it's this very bottom line, unless you know and are used to it. So if we wanted to do reduce on cupcakes, we would be trying to get the final price of a cupcake. So the old way would be to have our box of cupcakes, right? And we'd say, hey, you know, there's, I don't know, what I've learned from being in Europe is that there's a lot of value-added tax, especially with things with sugar, which the United States has none of, which is probably why all of us are obese. But, complete side note. So if you had a box of cupcakes, you start with your final price of 3, and then for each cupcake you would add $2. So since we have 4 cupcakes, we would keep going and adding up, and then we would get to $11 for our total price of cupcakes. If we were to reduce it, we would have our box of cupcakes, and we would say that the initial amount that we want to add to is 3, so that's why the 3 would be in parentheses. And then we would say for every item, add $2. So you would go through and your final price would be 11. It makes it a nice one-liner where you know your starting value is 3 and all you're doing is just adding for every single one you would add 2. It's similarly if we wanted to do something a little more fancy. So say I had some frosted cupcakes and some unfrosted cupcakes. Frosted cupcakes would be $4, unfrosted cupcakes would be $2. So what I would do in this instance is I would say, hey, my initial value is $3, but if my cupcake has frosting, I want you to add $4 to the final price. If it doesn't have frosting, I want you to add $2 to the final price. Since we have 2 with frosting, we would get a final number of 15. So again, this is just a lot nicer in that you kind of reduce the number of lines of code that you're using. So reduce takes 2 arguments instead of the 1 like we're used to with map, flat map, compact map, and filter. It takes the initial value and then it takes a closure with the arguments of the initial value of what you're adding everything to, and then the initial value / previous result, and then the collection item. And then you kind of take every item from the collection and go over it and kind of add to that result, and you only get a single value back. So again, this is really useful if you're trying to calculate the price of something and you have a whole bunch of items, if you're working on an app that has a cart or something like that. So why do we like all of this? You could do all of your code in the old way. It's perfectly fine. But a lot of people like this because you could kind of see this visually explicit chaining, and it ends up being a lot like what a lot of programmers are used to in JavaScript, where you just kind of have like map, filter, reduce, boom, 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 and you kind of can read through it and see what something does instead of having like 30, 40, 50 lines of code for a kind of small amount of stuff to do. So we're going to actually do all of this kind of in combination. So again, I've been talking about all these cupcakes, but say I went to a cupcake store and I wanted to buy 2 boxes of cupcakes. One of my boxes of cupcakes was an optional box of cupcakes, so I wanted to remove all the nils and all of that. The other box of cupcakes I wanted to frost. I want to combine these cupcakes since I only have one hand because I'm holding a baby. My baby doesn't like red cupcakes, so they have to remove the red cupcake afterwards. And then we want to get a final price at the end, right? So this is where it kind of all comes together. I used to have a slide with all of the old code kind of showing you how long it would be, but then it got really, really long and you couldn't really read it, so I kind of took that out. But we'll go over this step by step. So say the first box of cupcakes I have, they're all unfrosted. I want to frost them. So I'm going to map, and I'm going to say $0, first element of the array, go through every single element in the array and frost it. And you'll see at the bottom here, my cupcakes are now all frosted. My second box is an optional cupcake box. So we have some optional cupcakes and 2 nils. I'm going to use compact map to get rid of all of these nils and unwrap all of my cupcakes and make them real fancy cupcakes, right? So we have box 1 and box 2 down here. The next thing I want to do is combine my 2 boxes of cupcakes. If you remember, we used flatMap before to kind of remove a layer of complexity. So we're going to remove one of the outer layers of arrays and kind of combine them all. So now we're going to have this nice combined array of cupcakes. Next, we want to take out that red cupcake that my kid didn't want because he doesn't like red. So we're going to filter on the flavors, and we're going to say, sorry, if the flavor is not red, keep the cupcakes in. So as you'll see from before, we had that red cupcake, and now that red cupcake is going to be filtered out, and we're only going to have the cupcakes that aren't red. And then lastly, we want to reduce this entire set of things, and we want to get a final price for the cupcakes. if you remember how we did it before, our initial value is going to be 0. There was nothing that we're taking the price of, and then we're going to say, hey, add to that initial value $4 if the element in the array has frosting. If it doesn't have frosting, only add $2. And then at the end, we're going to get the value of $20, and we're going to know that we have to pay $20 for cupcakes. So that kind of, sorry, I'll go back to this, is what, 1, 2, 3, 4, 5, 6, 7 lines of code. And if I had done this in all the ways without using map and filter and reduce and compact map and all of that, you would have probably had around 40, 50 lines of code. It's a lot easier to read because you could say, oh, okay, I have my first box of cupcakes, my second box of cupcakes, and you could just kind of follow through like, okay, here's where I'm combining them. Here's where I'm taking out the reds. Okay, now I'm getting my final price, instead of having a lot of things that would be functions for each of these and then having to go back and forth between things. It's a lot more nicely readable and understandable. Okay, so to kind of go over this at the very end, map, as we've seen, basically is a nice shorter way of doing a for loop, and it goes over every single item in a collection and it does something to it. Flatmap is the same as map, except it kind of takes out a layer of things. So it takes out one dimension. As we saw, it kind of took an array of arrays and made it into one array. Compact map is also similar to map, but in this case it takes out all nils and it unwraps all optionals inside of it. Filter will see if things should be included or not included based on the include part of the function, and then it will return to you an array that matches all those things. And then lastly, reduce combines everything into one single value. Okay, that's it. Thank you.